Yeah, baby. Page 15. Still with me? Hey, I'm going to tell you all, this chapter is going to be a breath of fresh air. Meaning, you're going to do well. Now, that doesn't mean, oh, sweet, I don't do my homework. No, I'm not saying that. I'm not saying that. If you apply yourself this chapter, if you apply yourself as hard as you applied last chapter, this chapter, you're like, giddy up, I'm in. Okay?
Why does the book start on page 15?
Yeah, I don't know. Isn't it page 15 of the book? It is, right?
Yeah.
I don't know. And the page 15's on the purple side.
Yeah.
They made an error. It happens. All right. So, hey, friends, a polynomial. Let's just talk about what a polynomial is. A big old word. A polynomial. We've been dealing with polynomials. If you had like 2x plus 7, that's a polynomial. Okay? That's all it is. It's just a fancy word for like, hey, we got this math thing. All right? All right, so we're going to go, and I believe you have this, and it's on the purple side, I believe. So they have constant, linear, blank, cubic, blank. Okay? So I'm going to go down, and I'm just going to name what these are. So you have constant, linear, quadratic, cubic, and quintic. Okay, now, friends, I'd say the first three are the most vital to know. Constant, linear, or quadratic. Okay? And then degree, 0, 1, 2, 3, 4. Okay? Polynomials can go up to whatever degree, and I'll explain what a degree means in a minute. Okay, a constant. Constant is a number of some sort. Number could be a fraction, could be a decimal, could be positive, could be negative. A constant. A constant does not have a letter attached. So I'm going to put over here just no letter. No letter. You don't have an X, you don't have a Y, you don't have a W, you don't have a Z, nothing. There's no letter attached. So if I said, hey, the number 7, you're like, oh, Stirrup, you've got a constant going on. All right? All right. Linear. We've dealt with linear. Okay? Linear is something to the first power. So you have like 3x, or you have x minus 2, or you have 5x minus 3. Those are linear. Now, this is where the degree lands. This is to the first power, to the first power, to the first power. Okay? If I have x to the first, and x means the same thing. Okay? Make sense so far? Okay. So far in this class, we have dealt with constants and we have dealt with linear. Okay? We've graphed lines, right? Lines, linear, same thing. Quadratic. Quadratic could be like this, 5x squared. Or 7x squared minus 3, or 2x squared plus 3x plus 1. Those are all called quadratics. Quadratics are raised to the second power. So somewhere in the equation, you have an exponent to the second power. Okay? That's all it means. Okay, is anyone seeing the trend? No letter is a constant. Linear, our highest exponent, our highest power is 1. Quadratic, our highest power is 2. So what do you think cubic's highest power would be? 3. So this would be like 7x to the third. Or you could have something huge. You could have like 5x to the third minus 2x to the second plus 3x plus 1. Okay? Highest exponent is to the third. Okay? Yes, you might have other exponents, but the highest exponent, no matter what order it's in, the highest exponent happens to be 3. And that means it's cubic. Cubic. Third dimension, length, width, height, cubic. Ooh, wait a minute. Constant, degree 0, 0 dimension. Linear, first power, first dimension. It's got length. This is prepping you for geometry. Even beyond, we'll go beyond geometry. Quadratic, second degree, second dimension, length, width. Cubic, third dimension, length, width, height. Quintic, it's raised to the fourth power, 5x to the fourth, or you could have a big drawn out negative 3x to the fourth plus 5x minus 2, something like that. It's raised to the fourth power.
Then could it be like
Fourth
length,
dimension.
length, width, height, diameter?
A lot of times the fourth dimension is mistakenly called time. But by definition, a dimension is something you go backwards and forwards in. And right now we only know how to go forward in time unless we adjust the kinematic equations and take a particle of mass and accelerate it faster than the speed of light. Therefore, it will then go backwards in time. But the summation of all the energy in the universe is not enough energy to push the smallest atom with mass, which is any atom, to go faster than the speed of light. Dude, there's your physics for the day. Man, God, it's a good thing Stirrup knows is certified to teach all math and all science.
You did not expect for Miss Stone to yell at you and then Stirrup to give you physics. So this is definitely against the matrix right now.
All right, friends, so this is naming something by degree. Degree is the highest exponent. So first power, first degree, linear. Second power, 2 as an exponent, quadratic, cubic, quartic, or quintic. I mean, we can name all these Latin roots for it, but it doesn't really matter. Okay, so down at the bottom of your page, you have a monomial. I'm going to put a binomial here, trinomial, and then it becomes a polynomial after that. Okay, monomial, binomial, trinomial, polynomial. Mono means, in Latin, means one term. Okay, so we have one term. We have 3 terms. We have multiple terms. Okay, an example of a monomial could be like 7, which is a constant. We could have 7x. We could have 7x to the 5th power. Those are all examples of monomials. No, you don't have to have a base number of 7, but I'm just trying to give you a thing. We have one term, okay? We have only one term. And that one term could have a whole bunch of stuff attached to it, but there's only one term. A binomial is 2 terms. So you could have something like x plus 2. I have 2 terms. Think about bicycle. Bicycle has 2 wheels, right? Binomial has 2 terms. Okay, binomial could be like things like this. There's 2 terms. A term is separated by an addition or a subtraction sign. A trinomial has how many terms? 3. Tricycle has 3 wheels, 3 terms. So let's say we have x squared plus 4x minus 2. Or if I had x to the 5th plus 7x plus 3. Those are trinomials. Okay, and then a polynomial has a whole bunch. So let's change the world where we're thinking. That's a polynomial. I have 1, 2, 3, 4. I have 5 terms. So I got 4 or more terms. 4 or more terms. Okay, and these are just fancy ways of naming it. Now, these aren't the most important things in the world, but the leading coefficient is the number at the base of highest degree. Okay? So, I'm going to do this. I'm going to highlight the leading coefficient. This is the leading coefficient of this one. There's a 1 right there, there's a 1 right there, there's a 3 right there, there's a 1 right there. These are all them. So whatever my highest exponent has, an x or a y or some letter attached to it, there could be a base number. The base number is called the leading coefficient. Okay, so it's kind of the meat and potatoes. Now, friends, I'm going to tell you, shh, don't tell anybody. Don't tell anybody. But I'm going to make sure I have these terms written up on the board during the next quiz. The next quiz is in 5 minutes.
What?
Actually,
5 minutes?
You were listening. I'm just kidding. No, it's 6 minutes.
Man, we're really throwing kids off.
All right.
It just lives in the thing.
Big one.
Now we'll have a quiz. We'll have a quiz eventually, but it's not today. It's not today.
Okay, good. What's that? You will laugh. You wanted that.
All right. So my friends, we're going to get to something called standard form. Ooh, I'm going to take the comfy chair. Can I sit amongst y'all? So now I keep getting in your way. I'm sorry. Now I'm not tall enough to be in your way. Oh, thanks, man.
It should be the next page.
Is it? Nope. We're moving off that. I'm sorry. I had an extra thing. That is that the next thing?
Yeah.
Holy moly guacamole, look at the size of that in example 1. Are you kidding me?
It's a polynomial.
I think it might be a polynomial. All right. So, friends, I'm going to highlight this. I'm going to highlight this.
You highlight it?
And I'm going to highlight this. Friends, why did I highlight those 3 items? Why do you think?
Because they're the leading.
so they're all
Base to the second
Quadratics? Quadratics. Okay. So notice all 3 of those things I highlighted in pink. They all have an x. Agree?
Yes.
And x has an exponent, the power of a 2. Okay. So let's add these up. -4 plus 2. Hang on. Let's go. 2 plus 10. That's 12. 12x squared, right? 12 minus 4 is 8. So I get 8x squared. What do you think? Is that okay? I'm choking on my own spit.
What about the
Wait,
rest of
is
the
this
quiz?
like just?
All right, we're going to get there.
Are these like the same equations as like square footage?
Could be. Could be. All right. So does everyone feel good how the pink led to a blue answer? Now I'm going to highlight this. This one, and this one, and this one. Okay. Why did I highlight all those in blue? They all happen to be negative. You're right. What else?
No exponent.
There's not an exponent attached to the x, but there is a letter attached to a number, right?
No.
They are all also negative. So let's see. -2. So some cost $2, some cost $4. So that means I owe 6, right?
Yeah.
And then something I owe another 15. So I owe 21x.
That's a.
Okay.
It's not good.
All right. Well, that could happen.
You need to pay.
All right. So these I'm going to highlight in green. Hopefully you can decipher the difference between the blue and the green. All right. So my friends, why did I highlight those green? What are they missing? They don't have a letter attached. Good. All right. 3 added to 5 is 8. 8 added to 11 is 19. 19 minus 15 is 4. Positive 4. Friends, that big old colorful mess up above breaks down real nicely.
2, 3.
Yep, this is, so friends, so this would be a quadratic
Trinomial.
trinomial. Quadratic
That's a complicated name.
Trinomial. I know.
Does this look something kind of familiar that we've been doing?
Yeah.
Like what? Like what does it look
Combine
like?
like terms.
Combine like terms. Pretty much, right? So keep that in mind as we're going through this.
And you can't solve any further because they're different.
Okay, so let's take a look. Example number 2. When we see parentheses, things are grouped together. Agreed?
Yes.
So what number is in front of these parentheses right here? It's not really there, but we know it's there. Yeah. And there means there's one in front of this and one in front of this. So if I distribute 1 over stuff, thing, I can drop the parentheses and just get this.
Oh, I'm doing it on the wrong one.
Is that okay?
I was actually writing on accident.
Everybody see what I did? I just distributed 1 over. 1 doesn't change anything, but I dropped the parentheses. So let's go back to our routine. No, not Magic Pen. Magic Pen's kind of fun, but we're not going to use it right now. All right. Like term. What's another like term?
3x squared.
3x squared. Okay. And then?
Could it be that one?
And then x squared. Uh-huh. Okay, those are all like terms. They all are raised. They have the same letter. That letter is raised to the same exponent. So 5 plus 3 is 8. 8 plus 1 is?
8, 9.
So I get 9x squared. All right. And then we're going to go blue. All right. Like term, what's another one of those like terms?
Negative 10x and negative 4x.
Negative 10x and negative 4x. There's no others, right? All right. Some cost $10, some cost $4, so I owe 14. Good.
But the other numbers are going to add up to 0.
Oh, they do? Uh-oh. Is
Because
that really the case?
10 minus 11.
So 10 added to 1 is 11. 11 minus 11. Ooh, that's my answer. 9x squared minus 14x is my answer, which is a quadratic. I forgot a D there. Quadratic. How many terms are there? 2. 2 goes with what? Binomial. Good. Okay.
That makes sense.
I think I'm starting to understand this finally.
Me too.
Man, move down to example 3.
So then we just do the same.
Friends, looking at example 3 versus example 2.
It's the same.
Basically, I have a 1 in front of everything, yes?
Yeah.
Just drop the parentheses, distribute the 1, the parentheses drop. If you had a number out front, you distribute that number, but in this case, we have just 1, so that doesn't change anything. Squared plus 12x minus 4. All right. Highlighter. 3x squared, x squared, 12x squared. 3 plus 1? 4. 4 plus 12? 16. Okay. Let's highlight these as well. That. And then let's highlight this as well. All right. So you already told me it's 16x squared. All right. Negative 20. Something costs $20. Something costs $4. So I owe $24. I reach in my pocket. I got $12. So it means I still owe $12. So 12x. And then 9 plus 1 is 10. 10 minus 4 is 641,000. Like, really? This is a quadratic. How many terms? It's quadratic. Why?
Because exponent is only 2.
Because the highest exponent is 2. And then 3 terms is trinomial. And again, friends, guess what I'll have written up on the board in examples of each? I'll have constant, linear, quadratic, so on and so forth. I'll have it all up. We have a test. All right, I feel pretty good about myself. Can I get to that last example down there at the bottom? We good in the hood? There's no notes beyond this, is there? Is there not a second page? Is there another page? Oh, good. All right. All right. Hey, friends, perimeter. This is a rectangle. If the top is x plus 6, then the bottom is x plus 6. Do you agree?
Yeah.
If the left side's x plus 3, then the right side is? All right, so if I want to find the perimeter, I have to add it up. So I'm going to go x plus x plus x plus x. X plus x is 2x plus 3x plus 4x. 3 plus 6, 3 plus 6, 9 plus 9, 18. My perimeter of this particular shape is this linear binomial. So that's the perimeter. Oh boy, this is going to be tough. This is called a linear binomial. Okay. All right. I gotta use. Okay, I need some critical thinkers. Can it happen?
Yeah.
With me in charge? No. All right. So friends, how long do you think that side is? If that side's x and that side's x plus 2, how long do you think that little side is right there?
Oh, no, it's 2.
It's just 2. So follow me on this. If I go x plus 2, do I get x plus 2? Okay.
Yeah.
All right.
If you,
Yeah.
if you put the.
All right. All right. That was phase 1 of critical thinking. Phase 2.
The bottom
I have this added to this gives me this whole long side.
it's 3x. 3x.
So I get x plus 2x is 3x.
1 plus 1 minus.
Negative 1 plus 1. Oh, okay. Hey, if I wanted to find the perimeter, I'm going to add all the way around. So I have 3x plus x is 4x, 5x, 6, 7x, 8x.
Is that a negative x right there? Oh no, it just has a dot.
Oh, yeah. And then I have 2 minus 1, 1, 1 plus 2, 3, 4. Oh, that's also a linear binomial. Okay. So yes, you have some naming stuff that has taken place, but you have the notes on the previous page. Agree? Let's wait for you so I can look at you. You did nothing wrong. I just wanted to see what page it was. I didn't know what page it was. Hey, so this book is going to be off-centered by... Love it.
I just think it's funny because we rushed it, and I love it when we make mistakes. It's hilarious. Wait, so
You know whose fault it is?
it's not my fault.
It's Morgan's fault.
It's not my fault.
So take a look at the book. Does it match up? Yes, it's fine.
It's not Morgan's fault. It's not Morgan's fault.
It's Morgan's
August
fault.
15, 22.
All right.
I'm in charge of that.
Hey, friends, I would like you to work on page 17 and 18. Hey, I want to remind you of something, though. I want to remind you of something. Shh. If I go to CP Algebra 1 in Schoology, you still following me? Notice that purple folder down at the bottom. It says PEF, odd answers. So if we click that, and we're on PEF number 1, we click that, it's going to push us forward saying, open a new site. We're going to YouTube. And friends, that link has every one of the odd answers given to you done in order. It takes 3 minutes and 33 seconds if you wanted to do that. Okay? So that is something that's definitely available for you. So PEF answers. Odd on Schoology. PEF. It's the purple folder on the very front page. All right, come on. We're trying to make Stirrup rich. Every time you watch a video, I get half a penny. If you believe that, I'll sell you more bull.
It's like